Welcome back. We are continuing our discussion today on the graphing considerations of linear kinematics. In the previous video, we discussed the basic structure of these graphs. So in that video, we walked through the vertical motion of the elevator example. We walked through its positional graph, the three lines that shape those structures, the velocity graph, and then the acceleration graph of all the different phases of the elevator motion. And we made some important assumptions within that example that all phases of the movements were taking the same amount of time. Now we're going to take those assumptions away and start to build in a little more fun into these examples. So we're going to take these and build them, take them a little closer to home for us in the exercise science world. And instead of talking vertical motion of an elevator, we're going to talk vertical motion of some aspect of an exercise. And so today, we're going to walk through one of our big three lifts. These are the typical examples we start with of these types of motion. We're going to do a bench press. And so we're going to do the same sequence that we did before. We're going to graph the vertical position, velocity, and acceleration during a bench press lift. As we get started with that, though, we still need to talk about those same preliminary considerations that we did with the elevator that we need to do before every one of these problems and set up the stage before we get into the graphs themselves. So, remember those two questions. What is moving? And what is it moving in relation to as we start to set the parameters of these graphs, especially the position graph where we start. So for this one, typically the easiest place to start with a bench press or a squat or a deadlift, any of our kind of big traditional exercises that we will do this with. Again, we're doing a bench press. We're going to graph the motion of the barbell during the lift. So the actual barbell during the lift, that's what we are going to be graphing the movement of. Then, question number 2, what is it moving in relation to? Remember, for this one, the importance of that question is it sets up the parameters of how our position graph is going to look. So for the position graph, remember, you have your traditional y and x-axis, position on the y-axis. We'll stick in traditional meters for all of these over time in seconds. And that question of what is it moving in relation to tells us what the 0 is in the corner, again. And so there's usually 2 examples when I do this in front of a room full of people that I'll get thrown out to me when I ask the question, what is it moving in relation to? Either the chest of the person, which we can certainly do, or occasionally people will throw out to me either the bench itself or the floor underneath of you. And that won't make a huge difference, but it will make a small difference, and let's talk about what that difference is. If we make our movement in relation to the chest of the person, and we're going to do a full rep here because we're not quitters in this class. When we do a bench press, we're going to come all the way down to the chest and touch before going back up. And so, if we set it as the chest, that means that's our 0 down at the bottom. And so our position graph line is going to come all the way to the bottom of the graph because that represents our chest in physical, real-world space. Versus if we were to set the relationship to the bench itself, or even more, the floor of the gym that we are in. In that scenario, our barbell, hopefully, will never get all the way down there because the barbell shouldn't ever get to the bench underneath you, or especially the floor below you. Meaning, in your position graph line, it won't go all the way to the bottom of the graph. And so it's not a huge distinction, but it is an important distinction based on how we set these things up. So for us, we'll keep it relatively simple for the graph. We're going to do the barbell motion, that'll be our line, relative to the chest of the person, so we're going to come all the way down to the bottom of the graph at our 0 point. Now, with those parameters set, let's talk about what kind of lift we want to do so we can play with some of the movements in these graphs. Because again, before, with the elevator, we made assumptions that all of the timing and speed aspects were the same. Now let's intentionally change those up. So let's do an example where we can play with multiple parts of the speed component. What we are going to do is a bench press rep where we are going to unrack the bar, and our downward portion, the eccentric phase, as we lower the bar down to our chest, is going to be very slow. So we're going to be moving that bar really slow and controlled down to the chest. And then we're going to briefly pause at our chest. All of these components are important as we set this up. Slow down, pause at the chest, and then after that, explode back up. So the upward portion, the concentric portion of this lift, is going to be fast and explosive. So we're going to have these parts look much different now as we build them out. Downward portion, eccentrically, slow and controlled. Pause at the chest, and then explode back up really fast. So we can see the differences in how these graphs look. Now, we mentioned one other important note there. Let's also add it at the start. When we start this lift and we unrack the bar, we're going to give ourselves a brief pause of just holding the bar before we start any motion. And that'll give us a pause at the start of each of these graphs, and you'll see how that shapes out for the example that we do. Now, an important note before we dive into this, everything we just did there of setting the stage of the example, I will give you if you get questions about these graphs on a quiz or on an exam or on an assignment. Meaning, I'll give you what is the thing moving, what is it moving in relation to, what are the speed components, is something moving fast, is something moving slow, is something moving really slow, anything like that. And I'll give you the aspects of where is there a pause and where are there not pauses. All of that I will give you, because I have to give it to you, for you to outline these and draw them correctly. So, let's dive in. For the position graph, remember, we are graphing the barbell relative to the chest. So for this one, if the chest is way down here at the bottom of the graph, where should this graph start for this? If we unrack the bar and we are laying down and holding it, it's pretty far away from us. So it's going to start way up here near the top of the position graph. Because remember, 0 is the chest, and we're holding it out at arm's length, way above our body. So we're pretty far away from the chest. And remember, we set up where we are going to unrack and briefly hold this for a pause at the start. And that's going to represent our brief pause in all these graphs before we start any movement. So nothing's happened yet. We have simply unracked that bar. We are holding it above us and about to start our rep. Now, as we start to lower that bar, remember our 3 lines of the position graph. Those we still will have to use of speeding up, constant, and slowing down. But we said for this portion, it is going to be going slow. For it to be going slow in a timing component, that means it's going to take more time. And so we need to take those 3 lines that we talked about with the position graph, and to make them take more time, we're just going to stretch them out in this graph. So as we start moving, we still will have what we call line number 1 from before, where it's moving down, and it is getting steeper because we're picking up speed. We're just doing it really slowly. So it's getting steeper because it's picking up speed. We went from 0, not moving at all, to moving, so we're getting faster. We're just getting faster really slowly. So it's the same one, same line, just exaggerated and stretched out to represent slow movement as we go. Through the middle, we still have our slow constant. And then as we start to get to the bottom of this rep, to the chest, we have our slow, drawn out, flattening out line at the bottom. For number 3. So again, that's the same 3 lines that we used for the elevator. Getting steeper, picking up speed, constant throughout the middle, flattening out as it slows down. They're just exaggerated and stretched out to represent this taking longer. Now, at the bottom, we said we're going to have a brief pause there at the chest. So again, where we are now, we've unracked that bar and slowly lowered it down to the chest, and we're paused at the chest. That's number 4. So now we're about to explode back up. So we're going to be going back up, but now our line getting steeper for picking up speed and getting faster, instead of being exaggerated and stretched out to take more time, hopefully you can yell it at me through the screen of what we're going to be doing now. We're going to smush it together, make this much shorter and steeper, getting faster quickly for number 5. Because remember, we slow, lower, 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 pause at the chest, boom, explode back up. So that initial burst back up is really fast. Our constant period through the middle we still have, and it will be a short, quick burst of constant motion as we start to get into that slowing down portion, which here was slow, gradually controlled, versus here as we explode up, we're slamming on the brakes at the top. So we still have our same flattening out line, it just slams on the brakes and happens really fast. And so what we have in these phases, you have the lowering portion, down. So that's the lowering eccentric portion. And then you have the upward concentric portion. So upward concentric portion. So one, taking much more time, slow, controlled down, brief pause at the chest, explode up for these. Now, there is the rep of the position graph, just like before when we did the elevator. We use this one, changes in position over time, to then build the velocity graph next. So that'll look the same for axes, y-axis, x-axis in the middle, 0, positive velocities up top, negative velocities down below, y-axis representing velocity in meters per second over time in seconds. Now, as always, every corresponding number has to translate across every single graph. So we start with all of these as we go. That means our pause there in the position graph, we still have to have in the velocity graph. So that bar is unracked. We are holding it briefly before we have started moving in this rep. Start moving. Number 1, direction. Which direction are we going? Down. How do you know that from the position graph? The line literally is going down. So negative direction means we're going to be negative velocity over there. Remember, positive and negative sign. All that tells you is what direction we are going. And what are we doing? Speeding up, slowing down, or constant. Speeding up as that line gets steeper, but speeding up how? Slowly. So we're speeding up, getting further away from 0 in the negative direction, but we're doing that slowly. And so in that one, we're getting further from 0. We're just doing it slowly, so we have a very flat velocity as we go. It just doesn't get very far from 0, so we're just barely speeding up as we go. Number 2, negative direction, going down. Constant rate, so constant velocity. Flat line again. And then number 3, negative direction, still going down. Slowing down, this is starting to flatten out as we come to a stop. So we're going to be slowing down in the negative, so still on the bottom half of this graph, but slowing down meaning getting closer to 0, and slowing down how? Slowly. So again, this will be a relatively flatter velocity, creeping back up to 0, where we get to our pause, again, at the chest. So 1, 2, 3, and 4, again, slowly lowering down to the chest. 5, direction. Which way are we going? That line's going up, so we are now moving in the positive direction. What are we doing? Speeding up in the positive direction. And how are we speeding up? Fast. So we are going to be now top half of this graph, positive direction, speeding up, getting further away from 0, and speeding up how? In a hurry. So instead of a more flat velocity, this is going to be a steep velocity going up. So we're now moving in the positive direction. We're getting further away from 0, and we're doing it in a hurry. We just floored the gas to speed this up. So number 5, speeding up in a hurry in the positive direction. Number 6, our brief constant, moving quickly here in the positive direction. And then number 7, positive direction, still going up, slowing down as it starts to flatten out, and slowing down how? Again, quickly. We are slamming on the brakes, bringing this to a stop. So back down to 0, slowing down quickly as we go. And so for those, we have, again, our lowering eccentric portion and your upward concentric portion. Again, significantly faster on the way up than on the way down. Same lines that we've used for everything so far, just playing with their shape to represent taking more or less time. And in this scenario, bigger or smaller magnitudes of velocity, further away from 0 or closer to 0. Last, we have changes in velocity now again. over time. So we use that graph to build out our last acceleration graph of the bunch. Remember? Same axes. X-axis in the middle for 0. Acceleration, meters per second squared. Positive accelerations up top, negative down below, all again over time in seconds. All aspects, all the numbered chunks or smiley face chunks, all, you label them however you want to, all corresponding parts have to translate to every single graph. So we're going to start the acceleration graph, pause before we start moving, and then we ask the two questions about every single phase. Number 1, what direction are we going? Negative, because in the velocity graph, bottom half, negative velocity, negative direction. Position graph, going down, negative direction. So we know negative direction, doing what? Speeding up, further away from 0. So speeding up in the negative, it's a negative acceleration, and speeding up how? Slowly. So for this one, it'll be a negative acceleration, but a relatively short negative acceleration. Meaning it's speeding up, just not very much. Number 2, negative direction, but moving with a constant velocity, which again, velocity, constant, meaning not changing. So by definition, no change in velocity over time means acceleration, again, is 0. So this comes back up for number 2. 0 acceleration. Line number 3, negative direction, bottom half of the velocity graph. So still on the bottom, still negative velocity, meaning negative direction. Again, from here, number 3, we would say that line is still going down, negative direction. So negative direction, slowing down in the negative, positive acceleration, and slowing down how? Slowly. So what kind of positive acceleration? A relatively small one. Again. Number 4, we are paused at the chest, so we are not moving, so no movement, no velocity, no acceleration. Number 5, direction, positive, top half of the graph, so positive velocity, positive direction. Over here, how do you know? Position graph, line going up, positive direction. Doing what? Further away from 0, speeding up in the positive direction. What kind of acceleration? Positive. And now speeding up how quickly? Remember, this is an explosive movement, so we've got a positive acceleration, and it is a much bigger positive acceleration. So the magnitude of that acceleration is much bigger, because not only are we now speeding up, we're speeding up quick. Number 6, constant velocity means 0 acceleration, drops back to 0 for number 6. And number 7, direction, positive, still on the top half, still going up, so positive direction, slowing down back towards 0, slowing down in the positive direction is a case of negative acceleration, and slowing down how quickly. This is not a gradual slowdown. This is a slam on the brakes. So the magnitude of that negative acceleration, again, is big. For number 7. And so again, for all of these, what we have done is take those same 3 graphs that we did for the elevator. Same lines, same shapes, same trends. We've just tweaked them a little bit of stretching them out or squishing them together to take more time or less time. And we've had some magnitudes of velocity and acceleration get taller and shorter if we're representing big velocities, small velocities, or big accelerations and small accelerations. But all the other trends are the same as what we did in the first example of the elevator. So now we've talked through and shown examples of how these look when they're intentionally made slow, like the downward phases of all of these, and what they look like when they are intentionally made fast, like the upward phase of all of these. Now, there's one more little note that I want to give you on these 3 graphs of an example that we haven't done. And it has to do with the pause at the bottom. It's the only fold of the nuance of these examples we haven't touched on yet. So let's say, for these, that instead of lowering this down and pausing at the chest and then exploding up, that you are slowly lowering this down, and then it was a super rapid transition back up. So a fluid, rapid transition from lowering to upward motion as soon as we get to the chest. So we take this pause out, and instead, this just goes straight from downward to upward phase. Now, that's going to take away that numbered portion, so all of these would then change to 4, 5, and 6, because we took away the pause and we just went straight from the downward motion into the upward motion. And let's talk about what it changes over here on these two, because it gets a little different looking based on that. So again, the pauses here for number 4 for both of these. Hopefully you can jump around on the times of the video in case it gets confusing of what we're doing. All we are doing, again, is showing how this example would change if we took out the middle pause portion of this lift, so that instead of lowering, pause, up, it's just lower and then rapidly switch right back to up, and how this changes the graph. So we take away the pause, and I'll just take away this entire second half to show you what this will look like. The velocity and the acceleration. Velocity, acceleration. So now we're just to that middle portion. So for this, now we have 3 connecting directly into 4. So we still have, this is the same, slowly speeding up, coming down, constant through the middle, slowly slowing down for 1, 2, and 3. That doesn't change at all. The only thing different is instead of pausing here, we are going to transition right into the upward phase. Right into number 4, which remember is a fast, positive direction movement. And so now, this is going to get here and go directly into that rapid positive velocity. So all that changed there is we didn't have that little pause in between. Number 5 is still the same for our constant velocity through the middle. And number 6, we're still slamming on the brakes. The only thing that changed is we took out the pause at the chest and had that rapid transition in between, which gives us that little portion. What does that circled moment in time represent for us, where we switch from the negative to the positive of the velocity graph? Because remember, the sign of velocity tells you one thing only: direction. And so when you cross 0 in this velocity graph, and you switch from the negative side to the positive side, all that crossing over is you changing direction from down to up. Okay. And we just go straight from velocity number 3 into velocity number 4. And lastly, how does that influence our acceleration graph? So going through these with the accelerations, we still have our pause, going through each one of these to make sure we're following. Pause, speeding up in the negative direction, negative acceleration. Constant velocity for number 2, 0 acceleration. Slowing down in the negative direction for number 3, positive acceleration. And remember, all that lowering phase slow. So all those accelerations, relatively small. But now we go directly into number 4, which, remember, positive direction, top half, speeding up, getting further away from 0, so speeding up in the positive direction, positive acceleration, and speeding up how? Quickly. So it's a big positive acceleration. How do we now transition from 3 into 4 when we have a positive acceleration of 3 into another positive acceleration of 4? The way this will look, hopefully, again, you're saying it to me. If not, we go from positive acceleration here for 3 that was relatively small into another positive acceleration for number 4, which is just much bigger. So it just stair steps up from that acceleration it already was. If number 4 were a slower positive acceleration, it would stair step down. If it went somehow into a negative acceleration, it would stair step down to a negative. It just steps directly off of that one instead of going back to 0 during that pause period. Then the rest is the same. Number 5 is still a constant velocity, so we come back down to 0. And number 6 is still slamming on the brakes, slowing down in the positive direction for our big negative acceleration there. And so again, not a huge change when we take that pause away, but it does change the shape of the velocity and acceleration graphs a decent bit at that transition point. So now you have the example of the elevator, which is the basic bare bones of these graphs of what the lines should look like, making the assumptions of everything taking the same amount of time. And now we have our bench press example of the barbell relative to the person's chest with a slow portion, a fast portion. The original example done for most of this video included the pause in between the downward and upward phase. And then briefly here at the end, we've showed what that changes and looks like without the pause in between the eccentric and concentric portions of the lift. And then you've got position, velocity, and acceleration of each. That's all the variations that I can really give you of these types of graphs, is you've now got vertical motion slowly, vertical motion quickly, and you've got it with and without a pause somewhere in the movement. Those are all the different spins of this I can give you. So, to build off of this, you are going to have an assignment posted. It'll be just a written out question describing an exercise that a person is doing. It will tell you the setup, how we did here, of what your relevant words are hard for these videos. It will tell you what you are graphing the movement of, so what is moving. It will tell you what is it moving in relation to help you set up the parameters of your position graph and your zero at the bottom. And it will give you all of the aspects of where there's fast movement, where there's slow movement, and where there's any pauses or just fluid rapid transitions. So use these videos to complete those assignments. The submission Dropbox will be placed on Folio for those, and any other instructions for those will be up there as well. If you have any questions about this process, anything from the video about these graphs that doesn't make sense, please shoot me a message and let me know. I'll do my best to answer it as much as possible. And if you have any questions about the assignment itself, shoot me a message and ask me those questions as well. I'll do my best to answer as much as I can without necessarily telling you if you're right or wrong, which takes away from the integrity, of course, of the assignment. But let me know if you have questions on any of these. Again, to wrap up this video, we have gone through the position, velocity, and acceleration graphs of the vertical motion, up and down motion, of the barbell during a bench press, coming down to the chest slowly, pausing, and then exploding back up during the upward portion of that rep. And again, you've got position, velocity, and acceleration graphs of all parts of that. Please let me know if you have any questions on any parts of these graphing considerations of linear kinematics. Make sure to use these in your assignment for these graphing examples. And next up for us, we're going to start our discussion on angular kinematics, and I'll see you next for that.